on is going to talk about using the network structure. So I guess we have more scan the QR code or the environment. So I'm going to skip this page when I present. Right. Hey everyone, I'm Wei Yang. I'm a PhD student from University of Maryland. Today I'm going to talk about discriminative topic model using document network structure. This is a joint work with Jordan Forth-Graber and Philip Resnick. So I'm going to start with some motivations. In the real world, the documents are usually linked. For example, our paper has citation links with other papers like data distribution allocation, relational topic model, and with a stochastic block model. The reason that these links exist is that these papers share similar topics like topic models, document network, and block detection. So the goal of our paper is to make use of the rich information in these document links in order to improve topic model. And we will evaluate by replicating existing links and predict held-out links. Well, before getting down to our model, I'm going to have a brief review of the previous methods that deal with links. So the first algorithm is about block detection, which is to find densely connected blocks in a graph. So one of the block detection methods is strongly connected components, or CC, which is a deterministic method. It simply puts all the linked nodes into the same block. For example, here we have a document network, and if we apply CC on this network, it will simply put all the nodes, all the documents into the same block without considering the link density. And of course, this does not mean the reality, because we can intuitively find 3 blocks in this network. So we prefer a probabilistic method named with a stochastic block model, which is able to identify the 3 blocks in this network as denoted by the colors. So the way the stochastic block model only considers the links, but it does not take the content into account. So Chan Blind has proposed a relational topic model which considers the content and jointly models the topics and links. So the relational topic model is based on the latent distribution allocation framework. And here we have a 2-document segment of latent distribution allocation. It is able to infer that these 2 documents' topic distributions. So based on this, the relational topic model assigns each topic a weight. The weight indicates the correlations between the links and the document similarity on this specific topic. For example, if a topic has a high positive weight, then if the 2 documents have high proportions in this topic, then these 2 documents are very likely to be linked. So then the relational topic model composes a regression value based on this weight factor and the 2 documents' topic distributions, then put this regression value into a sigmoid function to compute the probability of the link. Okay, so next I'm going to talk about our model named LDH-RTM. So as a model is quite complex, so I'm going to focus on this example document network to show how our model works, but I'm still keeping the graphical model below just for your reference. So the first thing we want to do is to dig deep information in the link structure. So we first embed the weighted stochastic block model into the relational topic model framework. As I have mentioned before, with the weighted stochastic block model, we are able to identify the blocks in the document network. And to make use of the block information, we assign each block a duration prior to capture this block's topic distribution. And then, given given the assumption that the documents in the same block are likely to have similar topics, these division priors are used as informative priors by inferring the topic assignments of the documents in each block. And the second step is to add various features. So in the relational topic model, it only uses topical features to compose the regression value. But our intuition is that if the two documents are linked, they are also to be likely to have similar word usage. So that's why we add the lexical features in composing the regression value. Besides, in weighted stochastic block model, we have a matrix of link rates between any pair of the blocks. So the link rates is also kind of link indicators. So we are also including this feature in composing the regression value. And as usual, we put this regression value into a link probability function to compute the link probability. But instead of using the sigmoid loss that was using the relational topic model, we instead use a hinge loss function because this hinge loss function is able to make more effective use of side information by inferring topics. Okay, so we name our model LBH RTM because this is a relational topic model with lexical weights, block priors, and hinge loss. And to have a brief review of the model, I'm going to just have a summary of the different various components in this model. So the first component is the vanilla LDA. It is able to infer topics based on words. And the second part is the relational topic model with various features based on the assumption that links indicate topic similarity. This model is able to encourage linked documents to have similar topic distributions. So the last component is the weighted stochastic block model. This component does not understand counting at all, but it is able to find the blocks in the link structure and provides informative priors by inferring the document's topic distributions. Okay, so then I'm going to apply the model to perform the link prediction tasks. So we have two data sets. The first is Cora, which is a scientific paper data set with citation links, and a WebKB data set, which is web pages with hyperlinks. And during the evaluation, we train the model on the training documents and training links. And then we apply the trained model on test documents to get their topic distributions. Finally, we use the topic distributions and the trained weight vectors to predict the links within test documents, and also the links from the test documents to training documents. The link prediction performance is evaluated by predictive link rank, or PLR. So it's basically just the average rank of actual links. So for instance, for document D, we compute and sort all other documents by their link probabilities to D, and then we select the actual links and compute their average rank. So in this case, lower POR indicates better link prediction performance. And in order to show the contribution of different components, we are starting from the basic relational topic model and incrementally add components on RTM framework. So we incrementally add block priors, lexical weights, and hinge loss. So the general finding is that each component contributes to link prediction improvement. And as we have mentioned earlier, so there's another block detection method named strongly connected components. So we also try this method as a block detection component in the framework, but to our surprise, the link prediction performance of this LCH RTM is terrible. So why this, and what's the difference between the various models when inferring the document topics? So I'm going to pair of papers. So the first paper is using Fourier neural recurrent networks to fix sequential input-output data. And the second one is for neural networks, function becomes form. So from the title, you can intuitively tell that these two papers are about neural network. So I'm going to focus on the neural network proportion in the topics given by the various models. So let's start from the basic relational topic model. The RTM is two neural network topics. And the first one is about the activation function, and the second one is about the training algorithms. We can see from the figure, the RTM does not assign very high weights on both topics. So that's why the link rank of RTM is not so good. And then we add the block priors. In this model, we have only one neural network topic, and the proportions assigned on this topic is much higher. So we can anticipate that this model, the link rank given by the BSRTM is much better. And then in the third step, we add the lexical weights. So here we also have two neural network topics, but as we can see, the second neural network topic is not very related to neural network, but this model is accurate. It does not assign much weight on the second neural network topic. Instead, it assigns most of the weight on the first one. So link rank is much better. And finally, we add the hinge loss. So here, as we can see, there's only one topic, and the weight, from the weight we can see that this topic is dominating both documents' topic distributions. And naturally, this model is the best among all the models. And let's finally look at the LCH RTM, which uses CC as a block detection method. So it seems that the model assigns very high weight on the neural network topics, but unfortunately on two different subtopics instead of the same one. And let's look at the first one here. It's actually a combination of neural network and a leaf network. So that's kind of confusing. Then let's compare the LCH RTM with LBH RTM. The only difference is the block detection method. So from here, we can conclude that the strongly connected components is actually not providing correct prior knowledge to topic inferring. So that's why it greatly harms the prediction performance. Okay, finally to wrap up. In this paper, we propose a LBH RTM. It is a topic model for link prediction, and it is able to incorporate block priors from the links and include lexical weights and hinge loss in link prediction. And in the future, we are going to generalize this model to directed and undirected links and binary weights and non-negative real weight links. And we're also going to try some other tasks like link suggestions. Okay, finally, I'm going to thank all of you for your attention, and also I'd like to thank my collaborators, Dr. Graber and Philip Resnick, and I would also like to thank our funders. Thank you. I'm happy.
All right. We have 2 more extra minutes for questions, so fire away. All right, I'll start off. Can you apply, so you said in the future you're going to work on other links? Thank you.
Would it also be possible to work on basically any kind of adjacency matrix like, similarity measure between entities? So I'm thinking sort of, geographic similarity to detect regional variation, things like that. So we don't have an explicit link, but we have a weighted link. We don't have a binary decision, but sort of a measure of similarity of some sort, a kernel or something.
Yeah, so that's possible. We can model those real weight links by replacing the link probability function. Here we are using a sigmoid function, a point loss function that is specifically for binary links. But if we use like if we generate the links from like the exponential distribution or Poisson distribution, then we can model those real weight links.
Further questions?
Yes.
Can I ask how well this scales? It's one of the more complex diagrams that I've seen. Can you go beyond, you used about 1,000 documents. How high could you push this? How long did it take to run? And how big of a set could you use it on before it gets?
So, as I remember, if I run 100 iterations on one of the data sets like Cora, so it takes about an hour to train. Yeah, for 100 iterations.
Are there other larger data sets that have this kind of information?
Yeah, actually, now during the summer I'm interning at a company, so I'm applying this model on their data set. So that has about